Hi everyone. Last devlog I showed animations being created in Blender and being animated inside the game. But this devlog, I wanted to start working towards something that would allow me to use the animations in a meaningful way. So I decided to start working on building a terrain. Being solo, I do not have enough time to try to fiddle with handcrafting entire maps. So I went down a deep rabbit hole of procedural generation. From there, I decided I wanted to implement Perlin noise and generate a color map and a 3D view of the terrain. After that, I decided to learn about Poisson Disk Sampling, which I probably butchered that name, and implement that too for placements of objects such as trees, rocks, grass, pumpkins, whatever I decide. So what we're looking at here is the map generation tool that I wrote to generate the data that I'll need to actually create the maps, and then also have a little 3D viewer of the map scaled down by about a factor of 1,000. So this really should be about a kilometer by kilometer, but I just wanted to kind of get a feel for the terrain. And every time you run this, it will give you a new terrain, although I do have it randomly generating seeds, and I can store them to recreate the terrains, but I'm not really doing much with that now. And I'll go over a bit the algorithm for this, but basically it was pretty simple at first, but adding the Perlin noise made it a bit more complex, because not only do you have to check the sample for some threshold value for the pixel that the sample would be on if you're comparing with the Perlin noise, but you also have to check against all of the other sample types. So it's a pretty interesting algorithm, and I like so far the way that it's distributed. Even though it is randomly distributed, I can still have pretty good influence on where things will be placed. If you'll notice, the rocks in the desert, which would be the blue pixels here, they're also spread out through the grasslands, where the trees, minus a couple little spots of high altitude, maybe some hills or something, they aren't in the desert, nor is the grass, which would be the red dots. I think for a first prototype, this will work fine. In the future, I may add additional features to support perhaps a bit of manual editing. Here's an example of another map, and another one. And finally, another example, which I always like the ones that have sort of a mountain in the middle. The Perlin noise algorithm was not too difficult to implement. I decided not to use any noise library because I wanted to learn it more in depth. There are quite a lot of great tutorials and explanations for it, so I will not go into too much detail, but I did run into one issue that kind of gave a cool result. So this was due to not using the same random gradient for each of this sort of logical grid squares. If we look at the wiki, this might make a bit more sense. So if we take this example, you can see these squares kind of align with the squares that I had in the image. And these squares represent the pixels that would fit between two integers, if that makes sense. So imagine you're going pixel by pixel, and generally the rows and columns would be integers. Basically, you would multiply them by some small frequency to put them into the real number range, and then you would figure out their offset in this logical grid. The offsets are used ultimately for calculating the bilinear interpolation. So this is kind of how I think about it. If I draw a pixel here, let's say, this pixel will be between two consecutive integers. So if you get its relative position between those integers, you'll end up with a value between 0 and 1, which has a nice property that you can easily create direction vectors from these corners to the point, and I'm drawing with my mouse, so it's a little sloppy. And then you can take these direction vectors and calculate the dot product between the gradients, and then use these offset values and some smoothing function to do the bilinear interpolation. This is just my high-level interpretation of this. You'd have to read the wiki to better understand how to implement this, because I'm skipping over some details. One thing I would like to note from how I implemented it versus this depiction here is that the gradients here are random at each of these intervals, but actually in the improved paper, the gradients don't need to be random only the selection of the gradients do. So there's actually a set of gradients that can be used. And this is ultimately where my problem was. On the left side of an integer boundary, I was using 2 right gradients, but then on the right side of that same boundary, I was using different left gradients. They need to be the same gradients for the left side right gradients and the right side left gradients. The sampling algorithm also has a lot of tutorials, but the white paper was pretty clear besides a few implementation details. And as I mentioned earlier, I'm not only sampling now with one object's grid's neighbors, but I need to sample all of the object's grid's neighbors. So the original algorithm has a linear time complexity, but with my implementation, it's now quadratic. The core of the algorithm, however, is the same. For each new point, I basically grab a pseudo-random degree and a pseudo-random value between the radius and 2 radius, and check each type of object's grid to see if there's any overlap. The color map was pretty easy. I just looked at the pixel values and mapped them to a color and create another set of pixels. The main issue I had with this, and actually with all of the textures, is that I thought the OpenGL texture origin was top left when actually it's bottom left. So I had inverted things. That wasn't too hard to figure out. But the other issue I did not realize was that OpenGL gets a bit salty about having textures that are not a power of 2. And in OpenGL, you can't set this explicitly, but I did not know that. So it ended up padding garbage data at the end of the texture. The 3D grid generation was pretty easy, and I did it exactly how you would probably expect it to be done. But all in all, this devlog, I spent about 31 hours of work, most of which was me falling into the procedural generation wormhole of all the cool stuff that people are doing with it. Next devlog, I'm probably going to try to walk around on the map and work on lighting. It'll probably be a couple of weeks before my next vid. Also, considering as a father, it is my job to eat all my kids' Halloween candy, I will probably be in a sugar coma for a while. Anyway, thanks for watching. Take care.